Hello, everybody. Thank you very much for your patience with our late start as we work through some technical issues. This is Paul Lum with the American Farmland Trust, California region. I'm the California project manager, and I thank you for your attendance today. I'll start with introductions. With us today is our guest speaker, Dr. Charlotte Koch. Charlotte is a professor in the Natural Resources Management and Environmental Science Department at Cal Poly San Luis Obispo. Also with us is Samuel Madrigal of the American Farmland Trust California region. Samuel will manage the technical aspects of this webinar, such as the chat box and Q&As. So during the presentations, feel free to enter questions into the Q&A box. We're going to use the chat box for information related to running our webinar smoothly. We are recording the webinar and we will make it available. Well, at the end of each session, I'll address Q&As as well as the end of the webinar, and we'll take a 10-minute break after the second session, after Charlotte gives her talk. So our 4-part webinar series is titled Quantifying the Economic and Environmental Impacts of Soil Health Practices. So this webinar is the third in our series of 4. I'll start off today with a description about AFT's grower profiles in wine grapes. Charlotte will speak about compost research in wine grapes, and after our 10-minute break, I'll describe the NRCS T-charts that we use to estimate changes in income from different farming practices. This program is supported by the National Department of Food and Agriculture, USDA, through the Western Sustainable Ag Research and Education Program. About the American Farmland Trust. AFT is a nonprofit. It was founded in 1980. AFT's mission is to protect ag land, promote sound farming practices, and keeping farmers on the land. AFT's programs in California include Farmers Combat Climate Change. Do we have the webcam on? Okay. I just want to make sure. Let me know if you don't see the slide. AFT's programs in California include Farmers Combat Climate Change, San Joaquin Land and Water Strategy, Saving Farmland, Growing Cities, and Farms for a New Generation. The Farmers Combat Climate Change program includes on-farm projects to demonstrate soil health practices and develop grower case studies. The San Joaquin Land and Water Strategy includes programs to protect farmland and scale up regenerative ag practices. Our goals and purpose for our webinars, grower profiles, and training sessions are to increase farmer adoption of practices that improve soil health. Our focus is on providing tangible evidence of benefits of healthy soils, demonstrating economic and environmental tools to quantify benefits from healthy soils, publish easy-to-read handouts describing growers' success with soil health improvement, holding educational events and individual training sessions, and promoting the grower profiles to growers, the ag community, and the general public. Well, soil health. Why quantify soil health outcomes? There's scientific evidence that farming practices, such as cover crops, nutrient management, and compost applications improve soil health and water quality. but there's not much information about economic benefits from better soil health, and farmers want to know the bottom line. AFT has published 8 case studies across the US. They are developed and authored by AFT's staff and reviewed by economists and specialists from NRCS, USDA, and Colorado State. In California, 2 AFT case studies have been published evaluating almond orchards in Merced County and Madera County. Grower profiles in wine grapes are developed by assessing 5 healthy soils practices: nutrient management, conservation cover or planted cover crops, mulching of annual prunings, compost application, and minimum till or no-till. So today I'll highlight 2 California grape grower profiles: Mark Lyons of Ecoterreno Wines and Vineyards, and Julie Nord of Nord Vineyards. These profiles were written by California staff of AFT. And although these profiles describe vineyard operations, we can write profiles for many different types of crops and farming operations. The grower profile development, each profile consists of 3 elements. We include the grower's story, the economic findings, and the environmental findings. So going back to the story, we capture the grower's farming approach and philosophy towards sharing the grower's experiences with improving soil health. For economic outcomes, we quantify with the NRCS Level 3 T-chart. The T-chart allows us to calculate increases in income from changes in farming practices or losses from changes in practices. So I'll talk about the T-chart later this morning. And we quantify environmental benefit from soil health practices with USDA's nutrient tracking tool and USDA's Comment Planner. So our first profile was with Mark Lyons. We interviewed Mark. We learned of his winemaking background and about the history of the vineyard that we evaluated. Mark told us about his farming philosophy toward sustainable farming. He mentioned that his philosophy was influenced by his visits to wineries in France, where he observed how growers maintained soil health in their vineyards while producing high quality wines. Based on those visits, Mark began to plant cover crops and minimize tillage. He told us of his challenges with learning curves, such as trying different seed mixes and managing cover crop growth throughout the season. So our profile, I'm gonna go back. We'll start here. So the grower profile, we list practices that Mark has adopted since 2013, which were nutrient management, conservation cover, mulching, compost application, and minimum tillage. Mark says prior to 2013, we were tilling the soil to death. The changes I made to improve the soil are a long-term investment. So here's an expanded view of the first section of the profile describing the vineyard and including the story element. On page 2, we include the cost-benefit analysis in the form of a T-chart. And for the Ecoterreno vineyard, we found an increase in net returns due to improved soil health. And in the narrative portion of the profile, we also describe the environmental benefits using USDA's nutrient tracking tool and Comment Planner. So this slide shows website homepages for accessing the nutrient tracking tool and Comment Planner. And through these tools, we were able to estimate the following benefits for over a 7-year period since 2013, a 32% reduction in nitrogen losses, 52% reduction in sediment losses, and carbon sequestration equal to 760 acres of forests. So we'll describe how to use the nutrient tracking tool and Comet Planner at our upcoming webinar on December 1st. So how can ag professionals benefit from the grower profiles? The profiles can be used to demonstrate examples of grower success with improving soil health. We chose the tools that we use in the profiles because they're simple and easy to use. And we encourage you and the growers you work with to use them and to try different scenarios to see what farming practices might be beneficial and feasible, and or what changes might lead to cost increases. So ag professionals could inform the ag community, the general public, and the media of soil health benefits from practice adoption and of tools to quantify the benefits. But how can growers use the profiles? Growers could read about a fellow grower's experience with adopting healthy soils practices. We note that many growers know or are familiar with the profile growers, the growers that we profiled. Growers can learn to use the T-charts, NTT and Comet Planner to see what practices might work on their farms and the type of benefit, the type of environmental benefit that might be found from soil health adoption. Growers can share the case studies and tools with their landowners and crop buyers to improve communication and potential marketing opportunities. So in sum, the profile is a grower story of their experiences with improving soil health and their approaches to farming. We apply the level 3 T-chart to determine economic gains or losses from changes in practices. We apply the nutrient tracking tool and Comet Planner to quantify environmental impacts. And by publishing the profiles, we hope to demonstrate a grower's success with improving soil health, and we hope to train folks on using the tools. We're in the process of publishing additional profiles, and we hope to work with more growers in the future. We're also collaborating with other agencies on soil health projects and staying connected with university extension, crop researchers, nonprofits in ag research or ag outreach to further our goals to scale up adoption of sustainable farming practices. So here are some resources that you can refer to. AFT released a case study toolkit which provides step-by-step guidance on writing case studies and using the tools. That website address is on top. Reference to NRCS for T-charts and the environmental tools are below. And thank you for listening about our grow profile work. We can take Q&As now, and afterwards, Charlotte will speak about her work in Compost. I'm not seeing any questions. I'll give you one more second. Thank you. Give us just a moment and we'll segue to Charlotte.
Hello, everyone. Can you hear me?
I do.
Great, thank you. Nice to meet you all, and thank you very much for the opportunity to share with you today some of the work we are doing at Cal Poly. I will talk about a specific case study, a research trial, where we applied compost in a vineyard here at the Central Coast. But I'll start with a little bit of background for why we bothered applying compost in the first place. And it's probably no news to most of you that soil degradation is happening worldwide at an unprecedented rate. And this soil degradation manifests itself in a number of different forms. We see a lot of nutrient loss from soil that can cause severe problems in the quality of our surface and groundwaters. There's a lot of soil loss. This can cause air pollution issues, but it also causes a loss of really the most fertile top layer of the soil. And as we lose that nice topsoil, our soils become less fertile, which is not a good thing for the plants we're trying to grow. And on top of just soil loss through erosion, there's also a general loss in many agricultural systems of soil organic matter. Soil organic matter is the
sorry, Charlotte, 1 second. Could you pause for a moment? It looks like folks are not seeing your screen. Could you maybe try the share option one more time?
Yes. I'll do so. Can people see it now?
Oh, it looks like other folks were seeing it, and now folks are seeing. I think we're good now.
Great,
Sometimes there's
thank
a
you.
bit of a delay, so I think we're good though.
Great, good, thank you.
Mhm.
So soil degradation is a challenge worldwide, and because the soil degradation leads to all these different potential problems, there are a lot of policies and regulations that are emerging to try and deal with many of these issues. You might be familiar with the Ag Order, the state of California's Ag Order, which aims at trying to reduce some of these issues related to the loss of nutrients from our soils. That's a regulatory framework. But then there's also a number of incentive programs, like, for example, the Healthy Soils program came online, and compost application is one of these practices that is being incentivized through this Healthy Soils program. One thing that's really interesting about the use of compost as a way to try and reduce that soil degradation is because if we don't compost our organic waste, it generally ends up in landfills. And if that organic waste is in landfills, that's where it produces a lot of harmful greenhouse gas emissions. So California passed a bill to basically redirect a lot of organic waste through composting facilities, and that basically means that there will be more compost available, hopefully, to apply to soils to improve soil health. And so if our goal is to reduce soil degradation and improve soil health, it's important to think a moment about what we really mean about soil health. So soil health has been defined by the NRCS as the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. Now, while this is a really nice definition, it can come across a little bit abstract. So to put this in a little bit more pragmatic terms, we can think about the soil as, or we can think about soil health as or a healthy soil as a soil that is able to provide a number of really important functions. So first of all, if we have a healthy soil, we will want that soil to be able to support high yield and good crop quality. And oftentimes that is related to the supply of plant nutrients. So a healthy soil will be able to provide nutrients to the crop when the crop needs it, and at the same time retain these nutrients in forms that are not harmful to the environment to prevent environmental degradation from nutrient loss that could occur in periods of the year where the plant doesn't need these nutrients. Now, of course, a lot of that recycling of nutrients within the soil is basically controlled by the microorganisms that live in that soil. So then a healthy soil will also need high microbial activity and hold diverse soil microbial community. And it's not only on the nutrient side that we're concerned when we're talking about soil health. A healthy soil will also have an impact on the way water moves and behaves in the soil. So if we have a healthy soil, we would expect that soil to be able to hold on to a lot of water, but at the same time, we want that soil to have good infiltration and drainage so that we don't get anaerobic conditions in the soil that can harm the plant, or that we don't have a lot of runoff and actually lose that water to the ocean instead of holding on to it so the plant can use it later on. And the last function that is gaining more and more traction when we're talking about soil health is that potential of the soil to actually contribute to mitigating climate change by storing carbon in the soil, because about 50% of that soil organic matter consists out of carbon. And so in that way, our soil can actually help with reducing greenhouse gas emissions from the atmosphere. There's a lot of research that's being done worldwide to look into how soil health can contribute to supplying all these different functions that the soil can carry out, and how to measure what about the soil will help reach these potential goals. But I think it's important to think about the unique crops when we're thinking about soil health. What is considered a healthy soil for growing corn might not look the same as a soil that's healthy for growing wine grapes. And one of the reasons is that there's a lot of really interesting and unique attributes about growing wine grapes. Arguably, vineyards occupy about the broadest range of soil types among crops in the world. Back in Europe, when viticulture first started, a lot of the wine grapes were grown on marginal lands, on hills and on lands that were less fertile, because the farmers would reserve the more fertile lands for growing grains and for safeguarding food security. Then, as people started growing wine grapes in the New World, there was so much more land, so wine grape cultivation expanded into nice, deep alluvial soils like we see in some places in California. So it's really incredible the range of different soils that wine grapes are grown on compared to the range of soils you see for other crops. And then oftentimes vineyards are also on slopes to take advantage of the aspect and of the sun that is hitting these slopes. But that also means that there's a greater risk for soil degradation exactly because of these slopes. And then another interesting feature about wine grapes compared to many other crops is that they typically have a low nitrogen requirement. So the whole issue with nitrogen loss from agricultural systems polluting surface waters presents itself a little bit differently when we're talking about wine grapes compared to many other crops. Wine grapes are also perennial crops with deep rooting systems, so that really makes it that there's a lot of opportunity there to sequester carbon, because these roots are going to be able to pump a lot of carbon into these soils. And then wine grapes are not only grown to maximize, or management isn't necessarily trying to maximize yield, but it's a lot about the quality. So that changes in a way how we can think about soil health. And then lastly, wine, the consumers also have potentially increased interest that these wines are grown with sustainable practices compared to some of the commodity crops that we see. On top of all of that, the wine is very closely related to the idea of terroir. And so it has been shown that there's a lot of components related to the soil that help identify that terroir. A lot of these components are related to things that we can't really manage. They're inherent properties of the soil. For example, how deep that soil is, the mineralogy of the materials in that soil, the soil texture, the drainage class of that soil. These are things that might be hard to change through management. But at the same time, some of the things that we can change through management have been shown to be able to impact the flavor of the wines. For example, water holding capacity, nutrient supply have shown that in some ways these aspects can influence the flavor of the wine. So one way to think about soil health or a healthy soil in vineyards might be a soil that best expresses the terroir for that particular wine. In addition to the idea of the terroir, we can also manage a bunch of indicators related to soil health that might not directly affect the flavor of these wines, but could contribute to other potential benefits in these ecosystems. For example, the potential of these vineyards to be able to sequester carbon and mitigate climate change. I think it's a pretty appealing idea that you can mitigate climate change by drinking wine. That's a very soothing thought. So one way we can now think about improving that soil health is indeed by applying compost. It's one of the many potential practices that could help with creating healthier soils. And when we look across ecosystems and across climate zones and across cropping systems, there's quite a bit of research that's been done on the impact of compost on various of these functions provided by the soil. For example, it's been observed that compost can improve soil structure or increase nutrient retention, change the biodiversity within the soil, and so on. But there's not all that much data available on the effect of compost in vineyards specifically, especially when we're talking about vineyards in California or vineyards in the Central Coast region. At the same time, CDFA's Healthy Soils program is promoting this practice, so we saw a need to do more research, collect more data to provide growers with information on how compost could improve soil health in these vineyards that we find around here. We are wrapping up a project now that was funded through the CDFA Healthy Soils program to look at the impact of compost application rate on soil health. And in the photo here, you see Connie Wang. She is a master's student who's at Cal Poly who's been working with me over the last 2 years on this project. The project is set at J. Lohr Wines and Vineyards in Paso Robles. The field side is shown here in the picture, and this field is pretty flat, so the vineyard is not on a slope. The soil texture is quite coarse. It's a fine sandy loam. The block is Cabernet Sauvignon, and this block has a permanent cover crop in place. So it's been there for many years. And what they do is the cover crop, they let it basically grow over the winter months. As soon as it rains, it starts growing, it turns green, and then they just mow it and terminate it at the end of the season, but they don't fill it in or anything. They just leave it in place, and it naturally sprouts back when the rains come the next year. So in this context, we added compost, a compost trial in this block. And one of the factors in this trial was compost application rate. After talking to some viticulturalists in the area, it seemed like compost application was not entirely uncommon in the Paso area. And typically growers would apply somewhere between 2 and 6 tons per acre. That was also in the range of roughly what is recommended in or incentivized through the CDFA Healthy Soils program. But of course, if you apply 2 tons versus 6 tons of compost per acre, and you have to buy this compost from a third-party compost supplier, then it's going to cost you 3 times as much when you put on 6 tons compared to 2 tons, right? So we were interested in seeing how much of a difference it makes when you increase that compost application rate. Compost was applied in fall 2018, fall 2019, and we just applied a third season of compost last week. When we first decided how to apply this compost, we had quite some discussions about whether we wanted to band or broadcast that compost. And we ended up settling with broadcasting because of the cover crop presence. We thought the compost could potentially enhance the cover crop, and also because this project was funded by the Healthy Soils program, and we thought philosophically, well, we really want to improve the health in the entire vineyard, not just in the little strips right around the vines, right? So that's what we went with. Then we had our different application rates, and the source of compost was Cal Poly certified organic compost, and the main feedstocks for that compost are livestock manure and green waste. So then, after establishing the trial, we took a lot of different kinds of measurements. We took soil samples and measured soil organic carbon and nitrogen, and then some other indicators of soil carbon dynamics, including permanganate oxidizable carbon and mineralizable carbon. I'll talk more about what these tell you about your soil later. And then we also looked at aggregates and soil moisture retention. These two variables are still being analyzed. Then we also measured greenhouse gas emissions throughout the entire year in these fields. And then we also measured a few different factors in terms of the plants in the system. So we measured yield, we measured cover crop biomass, and then we also took samples to look at grape quality as well as nutrient levels in the leaf tissue, both of the cover crop as well as of the leaves of the vines. So let's have a look at what we found so far. We're still working on the yield data from this last harvest, but the previous harvest, we found no impact of the compost application rate 1 year after compost application on cluster weight. We also didn't see any impact on any of the quality metrics for the grapes that we measured. So then a lot of our data that we collected relates to this question of the potential to sequester carbon in these soils. And so when we're thinking about mitigating climate change and sequestering carbon, of course, we're looking at the carbon that ends up accumulating in the soil itself, but we also need to look at the CO2 that's being respired from these soils. And on top of it, importantly, there's another potent greenhouse gas that's emitted from soil, and that greenhouse gas is nitrous oxide. So nitrous oxide emissions are oftentimes associated with nitrogen inputs into the system, and because compost contains nitrogen, it is oftentimes expected that nitrous oxide emissions will increase under compost application. This is also what Comet Planner predicts. So this is here the results from Comet Planner when you're trying to figure out if you apply compost to 1 acre of soil at the rates recommended in the CDFA Healthy Soils program, what kind of greenhouse gas outputs or net results will we get? So Comet Planner predicts a net sequestration of greenhouse gases, but mostly due to storage of carbon into the soil, while it expects a little bit of additional N2O to be emitted due to this compost application. Now, this is based on a model simulation, and we were interested in seeing if this effectively happens in this vineyard in Paso Robles, given that our climates are relatively dry and our compost application rates are relatively low, we expected there was a chance that nitrous oxide emissions might not be as much impacted as we thought they would be. So let's have a look at what we found. Here you see the total soil organic carbon 2 years after compost application, and you see the levels in the tractor row versus the vine row at 3 different depths, 0 to 6 inches depth, 6 to 12 inches depth, and 12 to 24 inches depth for the 4 different compost application rates, 0 to 4 and 6 tons per acre. And in general, we see that there's more soil organic carbon in the tractor row, so where that cover crop is grown, in the top 6 inches of soil compared to what we see in the vine row. So that is a clear indication that that cover crop has been doing its job over the many years that it's been there and been accumulating carbon in the soil. We also see what is typically expected, greater carbon levels in the topsoil compared to the deeper soil layers, but no impact of the compost application at any rate, or at least not detectable statistically 2 years after that compost application. That's not surprising because it takes a lot of time to be able to build carbon in the soil. And so when we think about this conceptually, after you apply compost to that soil, you're going to have all this fresh organic matter added to that soil. And as soon as you add that to the soil, microbes are going to start to decompose that compost. As they do that, some of the nutrients locked up in that compost will be released, which could help with the nutrition of the vines, or could even help with improving the growth of a cover crop, for example. But at the same time, as these microbes are growing, they are producing byproducts. So here you have these byproducts, and it is these byproducts developed during decomposition that end up entering that soil organic matter pool, and that lead to an actual increase in the humus in the soil organic matter, the fraction of the soil that we know is so important for soil fertility. So this is why it takes time to be able to pick up a change in carbon levels, in total carbon levels in the soil, because this organic input has to go through this whole set of processes. At the same time, we can capitalize on understanding this process to be able to measure a few metrics that are a little bit more sensitive to changes in the management, and that can give us an indication of whether the system is moving towards carbon sequestration or not. And this is where permanganate oxidizable carbon, POC, and mineralizable carbon come in. So we measured this metric called permanganate oxidizable carbon, also sometimes referred to as active carbon. And that metric is thought to be a little bit of representative of what's happening here in this phase where these microbial byproducts are being formed. On the other hand, mineralizable carbon measures a burst in carbon dioxide after rewetting of the soil, and that is closely related to microbial activity and also is associated with a little bit of that loss of that CO2 associated with that microbial activity. So these metrics gave us a closer look into what's happening in the dynamics of that carbon sequestration. And so what we see here with permanganate oxidizable carbon is in terms of the depth and the location, we see a similar trend as what we saw with the soil organic carbon, the total soil organic carbon. But we do pick up an effect of our compost application rates here in that permanganate oxidizable carbon or active carbon. And our permanganate oxidizable carbon is increasing with increasing application rate. So this suggests that the system is moving towards sequestering that carbon that is added through the compost. And we pick up this effect all the way down to 2 feet deep. So this is really interesting because we applied that compost at these low rates, which is basically just a dusting, to the surface of the soil, and yet we're finding impacts after 2 years all the way to 2 feet deep. And we're not sure what the mechanism is for seeing that effect so deep, either because of the poor soil texture. It might be that some of that compost was able to leach down the soil profile, or it might be that the compost stimulated the plants, which then in turn stimulated the roots for putting carbon lower down in the soil profile. When we look at mineralizable carbon, we don't see an effect of compost application rate. So microbial activity basically remained the same across the different compost application rates. And we also see that when we look at the CO2 measured from the field over the course of these 2.5 years that we have data for, there is no impact of compost application rates on CO2 emissions. So basically, what goes in, a big portion gets sequestered, and there's not a larger portion that gets decomposed and blown up as CO2 as we're increasing that compost application rate. So that's really good news. And then when we look at our nitrous oxide emissions, the good news continues, because in contrast to what one could hypothesize based on what we understand about the impact of adding nitrogen on nitrous oxide emissions, we do not see an increase in nitrous oxide emissions with increasing compost application rate. So this is a number of good signs, even though we don't see or we cannot pick up or detect an increase in total carbon in the soil quite yet. There's a lot of indications that we are moving towards net carbon sequestration 2 years after that compost was applied. So some key findings for our study: there was no short-term effect of this compost application rate on the yield. We do see indications that the system is moving towards carbon sequestration, but we cannot pick it up quite yet in the total carbon. So this also implies that for the compost to really have an effect on soil health and really show its benefits, a long-term commitment to compost application is required. There were no environmental trade-offs between soil carbon sequestration and nitrous oxide emissions, which was really good news. And something that continues to pop up across studies in vineyards and orchards is significant differences between tractor rows and vine rows. And basically, in our study in soil carbon, nitrogen, toxi, and mineralizable carbon, but across the board, most soil health indicators that we've looked at across studies show this big difference between tractor rows and vine rows. So this means that we're really creating different kinds of soil health islands within these orchards, and I think that's important to think about as we're thinking about improving the soil health of these systems and choosing how we manage these systems. So then, taking a little bit of a broader look at this issue of compost application in vineyards, I'd like to share a few observations we made by comparing between studies. So this study at JLOR is not the only study looking at compost application in vineyards in California at the moment. There are a number of other ones, and we had some conversations with Josh Benson at Santa Rosa Community College, with Christina Lascano at UC Davis, and with Stuart Wilson, who's also at Cal Poly with us. And across different studies, we see that there's some different results that emerge from these trials. And some of the things that are different between these trials are, for example, compost application rate. Here we looked at rates between 0 and 6 tons, but Stuart Wilson did a trial in a degraded soil where they added up to 15 tons of compost. And so they found that they were actually able to rejuvenate some of these vines and increase the yield by doing this restorative management with this high compost application rate. Then another important factor to take into account when choosing to apply compost in vineyards is the feedstock. So in this case, we used Cal Poly's compost that is mainly consists of a feedstock of animal manure, but I think in a lot of vineyards, there's access to grape pumice as one of the feedstocks for the compost. And Cristina Lascano did some experiments in terms of phytotoxicity of different compost materials, and they actually found that the pumice itself shows some phytotoxicity, but after the pumice is composted, that phytotoxicity disappears. So compost feedstock and quality could really impact the way that compost will behave in the vineyard. Then you can ask the question, do you just want to apply it to the surface of the soil or incorporate it? In a trial in Sonoma County with Josh Beniston, they added tillage to the compost treatment as another factor to look at, and they didn't see any effects of the treatment on the soil carbon. So in their trial, this basically indicates that it didn't really matter whether they incorporated that compost through tillage or not. In general, one would think that if you incorporate your compost, you lose some of the benefits because of some of the destruction of soil structure due to that tillage. So I guess the judges are still out on that. When it comes to incorporation or not, it might be closely related to your timing of application. We purposely chose to apply our compost in fall because we didn't want to till it in, and we wanted to apply it shortly before fall rain so that the rain can help incorporate some of that compost into the soil. If you wanted to apply your compost to take advantage of some of the nitrogen release to meet your vine nitrogen requirement, you might want to apply it in spring, but then you don't have the rain, so you either want to band it and irrigate it in, or if you broadcast it, in that case, you might want to till it in so to make sure that it has contact with the soil. And then, of course, the question of broadcast versus banding has everything to do with what your objectives are for your vineyard. Are you trying to improve the soil health over the whole vineyard floor? If you have a cover crop in there, that might enhance the benefits of your cover crop by dusting some compost over there. So these are all variations on how we could choose to use compost in vineyards, and depending on these choices, we might be able to optimize the benefits that we're trying to achieve with our application. At the same time, there's still a lot of questions that could benefit from additional research to be able to have better decision making on how to implement the compost in a particular vineyard to achieve certain benefits you're seeking to find. That's all I have for you today. Thank you so much for listening, and I'd be happy to address any questions.
Yeah, it looks like we have a few questions for you, Charlotte. So the first is, what plants are used for cover crops?
Yeah, so it's mostly grasses. It's a mix of grasses. There's no legumes in the cover crops, and they sort of, it's just because they don't reseed it, so it just kind of like comes back every year.
Okay, great. And then someone else is, or the same person is asking whether the compost was applied along the rows as well.
Yeah, so it was just a broadcast. So it was just spread evenly over the whole vineyard floor, so to say.
And then another person would like to know when is the best time of the year to apply compost?
So I think it depends on your management objectives. So we chose to apply it in fall because we didn't want to till it in, and we were worried it was just going to blow away if there was no mechanism to have it go a little bit down in the soil. So we applied it in fall with the intention of having the rains have it go down the soil profile a little bit. But if you wanted to really get the benefit of some of the nitrogen release from the compost, you'd probably want to apply it a little bit before bud break, because typically what you see when you apply an organic resource like compost is that the nitrogen comes off in a bell-shaped curve about over the course of about a month following the application. So if you apply it in spring, keeping that kind of like bell shape over a month into account, you can match it with the nitrogen requirement of your vine. So it all depends, I think, on your objectives. What are the things you want to prioritize with your compost application?
Do we have any other questions for Charlotte? All right, looks like that might be all for now.
Okay, thank you.
Oh, sorry, there's a question. Can you overcompost?
I think you could. I think if you, you know, a lot of the growers we were talking to here in Paso were worried about going more than going over 6 tons per acre, because they're worried about getting too much nitrogen in the system and boosting too much vegetative growth, which could negatively impact the quality of the grapes. I think another thing to look into if you get compost is to make sure that it's from a certified source, and usually they'll have they should be able to provide a report with the quality of that compost. And some compost can be relatively high in salt, so that's another thing to watch out for. If you apply really high rates of a compost that is relatively high in salt, and that would often occur if you do have a manure-based compost, that might cause some adverse effects. So I think, you know, keeping rates lower and maybe moving towards a more green waste feedstock for your compost would reduce the risk of potentially adding too many salts into your system.
Looks like we got some more questions now. So there's another question here is asking if compost can affect the quality of the grapes.
We haven't seen any impact in our trial of compost on the quality of the grapes. In the study I will briefly mention that Stuart Wilson did up in Lake County, they added high amounts of compost. It was a really degraded volcanic soil, and they added up to 15 tons. They saw an increase in yield, but no influence on the quality metrics they looked at. So I'm not, I haven't seen any strong evidence of compost changing the quality of the grapes, but there are definitely studies showing that a change in nitrogen management could impact the quality of the grape. So I wouldn't say that it's not possible that it impacts the quality of the grape.
Great. And then someone is asking if you're recommending compost tea spread as foliar, and I wonder if that means foliar spray.
I have to admit, I know very little about compost teas. The Upper Salinas Los Pablos RCD started a Healthy Soils project last year, looking at compost tea and vermicompost in it's at Costero Cellars in Paso Robles, and they're still working on the data. I am a collaborator on the project, so we're very much looking forward to see what that looks like and to be able to provide some more information. But I don't know of much data out there in the scientific literature to really be able to say, to answer, you know, to like say what to recommend at this point.
Okay, and one more question. Someone is asking, are there any standards set for compost quality?
Yeah, so some of the things that the labs look at is the maturity of the compost. So if your compost is not mature, it will continue sort of like composting when you apply it, and that could cause ammonia formation in the soil, and it could cause temporary immobilization of nitrogen during that composting process. So you definitely want to apply a compost that has passed the maturity test. And then another thing that's important to look at is the carbon to nitrogen ratio of your compost. If the ratio is higher than 10, especially if it's higher than 20, your compost is probably not really going to release very much N. If it's higher than 20, it could actually even immobilize some N instead. If it's lower than 10, you can expect that there will be a net release of plant available nitrogen into the soil. So if you are applying compost with one of your objectives to help with nitrogen nutrition, you know, applying it in spring and getting a compost with a low C/N ratio would be a good option. If that's not your objective, maybe you want to choose a high C/N ratio compost with, and then maybe you want to apply it in fall, for example. So C/N, maturity, and then looking for the salts is a good idea. Some composts could have some heavy metals, but I think most places that certify the compost would make sure that these heavy metal levels do not exceed certain levels, because otherwise they wouldn't be able to commercialize it. So yeah, I think these are the main things to look out for: salt, C/N ratio, and maturity.
Well, thank you, Charlotte, for your very informative and interesting presentation. And I encourage you all attendees to view other presentations that Charlotte and her staff have presented through podcasts. They are online, very interesting, and include information on vineyard practices and its effects on soil health, in addition to a lot of other vineyard management topics. So, and to add to Charlotte's talk, at our next webinar on December 1st, we're going to talk about the carbon sequestration and a tool to measure greenhouse gas emission with Comet Planner. So we're now going to take a 10-minute break. We'll resume at about 10:25. So we will see you then. Thank you. Break. We're now going to talk about a method used to assess economic impacts from changing farming practices, changing crop practices and inputs. We hope this instruction will help you learn how to use a basic tool for evaluating whether changes in practices might be advantageous. So we're going to focus on the NRCS level 3T chart, a cost benefit analysis used to compare two options. So in our case, we're comparing farming costs between one scenario with another scenario. So it's a simple and basic method that growers could use to guide their operations management. So for your farm, you could estimate benefits and costs from changes in farming operations. It focuses on only the variables affected by the change in farming practices. And a comparison is made between the before scenario and the after scenario costs of practice adoption. So an example might be comparing the cost increase from compost application with the cost decrease from reduced fertilizer application. So NRCS published a document or economic technical note, the basic economic analysis using T-charts. It's available online and it describes the T-chart method for NRCS conservation practices, but the method can be applied to any farm practice changes or evaluation.
Hey,
We're
Paul,
presenting this method. Yes.
I think you might have somehow stopped sharing your screen.
Oh, okay.
Okay, you're back.
Okay. And everybody heard the prior, the start. So, okay, so I'll start here since you heard the intro. So NRCS published this document. It's available online and it describes the T-chart method for NRCS conservation practices. But the method could apply to any farm practice changes. We're presenting this method to increase awareness of the tool and encourage using it when assisting growers with decision making and planning. So here's page 1 of the publication. There are 3 levels of T-charts. I'm going to walk you through each level. Level 1, level 2, and level 3. Level 3 is the most effective T-chart, and I'll describe each one and then focus on level 3. So the T-chart is based on partial budgeting, which is the accounting of cost changes from a baseline period or past period compared to the current period, or accounting from the current period to a future predictive period. So another example, an example could be comparing your herbicide and mowing costs from 5 years ago prior to cover cropping with mowing costs from this year after adopting cover crop planting. The value of the benefit and cost analysis, again, to assist growers with estimating economic effects from adopting soil health practices, identifying monetary benefits, and identifying negative impacts or costs. The economic analysis requires 4 steps. So estimation of farm input costs, estimation of benefits, converting values to like terms, which I'll discuss a little bit later. Those like terms might be cost per acre for all of the inputs, and comparing costs and benefits. So this method assesses inputs and benefits related to the specific field being studied or the specific practice. So for example, a large equipment purchase, such as tractors or irrigation systems used across the entire farm, would not be evaluated, but the purchase of a cover crop seeder for the specific vineyard or field might be applicable. Annualized costs are used for large equipment. For example, a 10-year annualized cost entered in the T-chart. So this is the basic T-chart template. Positive effects are entered on the left column and negative effects on the right. The positive effects refer to cost reductions from specific practices or increases in income due to increases in crop yield or price points. And in our case, we're focusing on how soil health affects costs and yield. Negative effects on the right could be cost increases from practices and income decreases due to yield reduction. And the net effect is simply a subtraction of the negative effects from the positive effects. The T-chart level 1 is the most basic chart. Entries are qualitative statements, in this case from the grower, for each practice change. So in this table, the positive effects for the grower, stating a decrease in fertilizer applied. For negative effects, the grower states increased costs due to the purchase of a no-till drill. This T-chart's a summary of conservation practices. It's less time consuming. It could be very useful to see the number of tasks and practices involved with growing a crop, and to see its general benefits or detriment. But it doesn't provide quantified findings. And a wine grape grower might list, for example, using this chart, a wine grape grower might list the number of pruning passes or leaf pulling passes, but not the labor costs, or listing the number of sprays, but not the costs. So this is a quick way to see the overview of practices required to manage a crop. The level 2 T-chart includes quantitative values for each input and for revenue. However, the values might be entered in unlike terms. So for instance, reduced tillage in dollars per acre, but reduced fertilizer in pounds per acre. So this chart has more information than the level 1 chart, but it doesn't provide findings for a net benefit or loss. And here's the level 3 T-chart example. And I realize this isn't very clear, but this is the overview. This T-chart, level 3, includes crop inputs and revenue, all in per acre values. So it's much more time consuming to complete, but it's more comprehensive and valuable in the sense that you can find a net benefit or net loss value to farming inputs. So it's a much better planning tool for considering changes in practices. The premise of the parcel budget analysis using level 3 T-chart could be to compare inputs and yield from a particular year before practice adoption with a current year. So for the sake of accuracy, it might be necessary to use an average of several years before the before scenario and after scenario to account for cost or yield variations due to weather, pest pressure, and other annual variables. Adjustment for inflation might be necessary. And for entries and changes in revenue, it might be necessary to use weighted averages for annual yields to average out the changes in yield due to seasonal variations, again, perhaps due to weather conditions or pest pressure. It also might be necessary to adjust for inflation or decrease prices due to market variation. So when developing a T-chart, here's an example of farming inputs that might be listed. Fertilizer, herbicide, and the rest of the items on the list. You could play with the numbers and see the results from increasing or decreasing inputs. So for example, you could enter $20 an acre, reduce fertilizer costs due to composting, or you can try entering $30 and calculate the bottom line, or you can predict cost increases from cover crop mixes. We encourage the use of the chart to find the impacts to income from specific practices and changes to see if there's benefit, if there's value in changing your farm management. So for the Ecoterreno grower profile, here's an assessment that's in the profile using the T-chart method. And I know you can't see the line item values, but this is a good farm example because Ecoterreno made many changes in inputs as they adopted healthy soil practices. And growers that participate with NRCS programs often complete the T-chart table to help with decision making and budget and guiding for budgets as part of participating in NRCS programs. But for the sake of today's webinar, we're presenting a T-chart as a method to assess costs and benefit from practices that improve soil health. So for this chart, shown in the upper right are the grower's resource concerns listed and baseline management practices. On the upper left are the conservation practices that were adopted and the year of adoption. So the totals for the positive effects and negative effects are shown at the bottom of each column, and the net benefit or loss shown in dollars per acre. And on the positive side, for Ecoterreno, showing a net increase in income. So here's an enlarged view of the positive effects column, showing savings from decreased nitrogen application, for example. So I've just isolated fertilizer, and you can see how the cost reduction from the prior scenario using UN32 and CAN 17 applications compared with using UN32 and ATS blends, and there was a slight reduction in costs. And so we realized fertilizer and other inputs are different for every grower, and we're not advocating any specific practice, but our aim is to train folks on the tools to assess the benefit or loss and hopefully demonstrate gains from healthy soils practices. Here are some resources available, information and access to T-charts and NRCS practices, cost studies. And as Charlotte mentioned, be sure to look at the CDFA Healthy Soils programs to see if any of those programs could be valuable. Individual assistance is available. Part of our program is to provide one-on-one training and to help growers and ag professionals learn about our, the case studies, grower profiles, and the tools we use. Upcoming webinars we'll be holding on December 1st, and we'll cover the environmental tools related to water quality, soil health, and climate impacts. So we'll send announcements out soon, and we'll also let you know of webinars upcoming to be held in January. So this concludes our webinar today, and thank you for sitting in. To recap, we discussed the grower profiles. We heard from Dr. DeCock about research on compost applications, and we covered the basic use of the level 3 T-chart. So we hope you can share this information with your growers, and shortly we'll be emailing a link to the grower profiles, to the recording of this webinar and an exit survey. I want to thank Dr. DeCock again for her very informative talk and for her participation with our webinar. So we can now address Q&As before we sign off. I don't see any or hear of any. Thank you. If any Q&As come up later, feel free to reach me. And again, I appreciate your attendance and look forward to seeing some of you on December 1st. Thank you.